Hi, we look at the importance of identity and access management, two of the key areas of information security today, and in fact, perhaps the most important area. Because what are we trying to do with access management? We're trying to control who gets on our system, and what can they do when they get there? Let's start with a quick review of physical and logical access controls, certainly a part of access management. We're going to look at the identification and protection of assets throughout the asset lifecycle, which includes, of course, these areas of physical and logical access controls to those assets, identification and authentication, authorization and access permissions, single sign-on, and the identity management lifecycle. We start with looking at access to facilities. We talked back in the security architecture domain of how this was a layered defense, and physical security often is a good example of how we put in a series of different obstacles to prevent unauthorized access to something of value. We also know that many times today access to facilities is integrated with access to our logical systems, our networks, desktops, and applications as well. We often manage this through the use of ID badges, such as a photo ID, though some of us would question if we ever really looked like the photo on our ID badge. But you want to have an ID badge, which is difficult to duplicate. Maybe it has holograms on it, so it can't easily be recreated by somebody with a color printer, for example. Quite often, our ID badges also are a smart card that are used to log into a system through some type of a reader. We should have a clearly demonstrated expiry date, so we know when this ID badge is no longer valid, and linked to this should be our access permissions. When we look at access management, this is a life cycle. It starts from the time a person first applies for access, part of the registration process, through the maintenance of their access rights and privileges, and those change as a person moves through the organization. Quite often, we end up with this problem of a person's access is cumulative. In other words, they keep adding more and more access to things that now go far beyond what their current today needs are. As a person moves into a new role, some of that old access should be removed. We then see when a person leaves the organization, the life cycle terminates with the revocation or termination of that access. One of the things we have to prepare for is forgotten passwords and forgotten usernames. This is where it's good to have a recovery process that is also trusted. How do I know that if I'm issuing a password reset, it goes to the rightful owner of that ID, not to somebody else trying to get another person's ID password reset? One of the areas that we look at, especially in access to facilities and physical access, is the use of security guards, and our security guards need the appropriate training as to ensuring that they know when to allow people in and when not to, as well as protection from social engineering. Social engineering could be a person tries to create a disturbance and threatens them that they're going to go to their boss if they don't let them in. And that's the sort of thing that we have to tell our security staff. No, if a person does not have the right ID card, they don't get in. They cannot convince the security guard to do something which was against the policies and procedures that were then provided. We also realize that people quickly become desensitized. If a person is monitoring ID badges, after a few minutes everything becomes a blur. And quite often we need to rotate those people every 5 to 7 minutes so that there's a different person at the desk just checking IDs so they're alert and able to pick up if a person has an ID that belongs to a different person or an ID that is fake. This idea of being attentive is important because it's too easy to fall into this hypnosis type of state where they're not really seeing if a person is doing something wrong. A security guard is also a type of compensating control. A compensating control is a control that makes up for a weakness or a vulnerability in other controls. And if we have turnstiles or a man trap, or we have some type of control which is there to physically prevent someone from getting unauthorized access, we need a security guard in case that person needs an exception, or it's a visitor or someone bringing in some products, and we need to be able to open up the gates to allow this person in. One of the important areas of all of this, of course, is segmentation or separation of different work areas, for example, and separation between employees and visitors or contractors as well. This starts right out at the facility level, maybe having a separate parking area for visitors. A person entering the parking area must have a parking pass that indicates where they are allowed to park, for example, and that they are a visitor. We should quite often have a separate entrance. Visitors have to come in through the security guard at the front desk, make sure they have the correct registration, whereas employees may be able to get in a side door just using their ID card, for example. We should ensure that when we are dealing with a high-risk area and an escort is required, that is indicated not only on their temporary ID badge, but the person who signs them and must realize this person needs to be escorted and cannot just have free run of the building without any type of monitoring. We quite often will issue a temporary pass, and we may even issue this to employees who forget their badge. But this should be something which is only good for a limited amount of time and must be returned, say, at the end of that time period. We should have a clear policy that says everybody should have to display their ID card. If we're dealing with a sensitive facility, there should be nobody walking around that we cannot clearly see what their access permissions are through their ID card, which is very visible, and they have not hidden in their pocket, for example. We should make sure that these are returned at the end of the day, and one of the ways to do that is to ensure that when a person is issued a temporary pass, maybe they have to hand over driver's license or a passport or some other type of identification that they would have to retrieve when they return their temporary pass. Now, this depends, of course, on things like privacy laws and so on as well. Sensitive work areas should be protected using things like multi-factor authentication, signage that indicates "do not enter unless authorized," for example, and the correct vetting and review of contractors or cleaning staff. Make sure we don't have people that are going into a sensitive work area to do cleaning that maybe are not trustworthy and could be viewing things that they shouldn't be able to see. We should also ensure that our access control devices are correctly maintained. They're tested regularly to make sure that they're working, and that means, of course, that they're properly cleaned, maintained, and we attempt to get in with invalid cards to see if that will let us in, for example. Logical systems access. We reviewed the areas of physical and facilities access, but now let's look at the area of logical systems access. This starts with, say, for example, access to the desktop itself. Do we use multi-factor authentication? We hear that for almost everything these days, making sure you have a combination of what you know, what you have, and what you are, whether or not we have a reader attached to the desktop, for example, to ensure that we provide a stronger form of authentication than just a password, for example. We also should have policies and then backed up through various procedures that deal with the area of, say, a screen lockout or a timeout. If a session has not been used for a few moments, it locks out so that it cannot be used by somebody else. Also, we have a screen lockout so that we don't have sensitive information sitting on a screen when a person has walked away to get a new cup of coffee, for example. We use card readers in order to ensure that a person can only log into that desktop if they have the correct card that they can insert into that reader at the time. We also need to provide access controls to networks. Especially, there can be a difference between being on a wired or a wireless connection, and we need to ensure that we are using proper forms of encryption for our traffic, especially in a wireless type of a world. But in all of these, you don't want to have open ports that a person could easily connect to this cable and get access to our corporate network. We want to ensure that we monitor and control remote access. We have many people now that telework or they work remotely, and that's great, but we have to make sure that that access they have cannot be misused by somebody else, either through the compromise of that person's machine or the compromise of the network connection. Sometimes we'll even do node authentication, which means we will only let a person connect if they're at a pre-registered IP address or MAC address, or a certain geographic location. Now, having said that, we know that all of these can be spoofed. You can spoof a MAC address. You can spoof an IP. But the whole idea is, it's one more layer of authentication to try to make sure it's only an authorized user getting access from an authorized device. One of the ways this is often done today is through the use of certificates. We will issue a certificate that must be exchanged by that endpoint device trying to connect to the network access server. We also see the use of trusted platform modules that chip on that endpoint device that authenticates back to the network, so we know that this is a legitimate machine connecting at the time. Then we look at access to applications. This is often done, as we know, through the use of a password or a PIN number or a passphrase. But where this becomes a problem is when you have an application that calls other modules or calls other process threads. That call between an application and a process thread can be done at a privileged level, but the original user is not at a privileged level, so the risk comes when a person is able to gain access to sensitive information beyond what their correct permissions should be, because of a lack of a checking of those called modules. We always have the risk of someone taking over sessions somebody else has already set up. This was used a lot in attacks like cross-site request forging and other types of session hijacking attacks, which is why we quite often would put in what we called periodic authentication. Every 10 minutes we'd go back and re-authenticate that person, ask them to enter in what a value was on their, say, token, for example, at the time. But today we're getting much more into the area of continuous authentication. They're being authenticated all the time through a USB-mounted key fob or a card that's plugged into a reader, so the moment anybody would intercept the communication, then try to hijack the session, it would break that authentication connection and immediately terminate the session. It is important we use logging: who logged in, but also what changes did they make? What data did they access? So we have a record, which is necessary if we're doing some type of compliance review or audit. We protect as we become even more granular, right down now to the data level, and we can protect access to data through things like encryption, the filtering we use on a database called a database view, which limits what fields or columns a user is able to see. We also can hide information through obfuscation or masking. So when a person's entering in a password, for example, it cannot be viewed through shoulder surfing or someone looking over somebody's shoulder to see what their password or PIN number is. Instead, we only showed us a series of dots or asterisks. We want to make sure that sensitive information cannot be disclosed to even someone who sets up a camera to try to pick up what a password or PIN number is. One of the ways we can also do this is to substitute the sensitive information for a token value, something we call tokenization, and used a lot when we're dealing with payment cards. A merchant does not need to know the card number. Instead, the merchant's bank issues a token value that says this transaction was completed, and only the actual customer and the bank know what the true card number is. The merchant only gets a token value in case they had to dispute that charge in the future. It's also really good to use screen filters. I think we've all been amazed sometimes when we see a person in a very public place, a coffee shop or an airport, open up their laptop and start working on sensitive information. Maybe they're working on this report that they have to deliver, and there's data in there that a competitor should not see. So the idea of having a good screen filter so that others that are sitting beside are unable to see it is a really good idea. Protection of information assets. We protect information assets, for example, in reports. We have reports that may contain sensitive information, and we have controlled distribution so that only the authorized people actually have access to that report. We make sure those reports are clearly labeled: this is for official use only, this is business private, this is secret, whatever the appropriate label is, so everybody knows, oh, wait a second, this report should not be left lying around, or the contents of it should not be shared with anybody who is not authorized. We keep our information safely stored. Maybe it's in a locked container or filing cabinet, so that those reports, they can be retrieved when necessary, but they're not just available because they're sitting around on a desk or they've been discarded in the recycling bin. This means we also will shred them. Things that have sensitive information should be securely disposed of. And this is where a good crosscut shredder, for example, can be helpful. We've seen cases where with ribbon shredders people have taken the time to reassemble a report. So it's important for us to securely shred, and in some cases, even then burn those shredded reports. We also have to protect where we have data on portable media. And portable media, whether or not it's on a camera or a USB, on a portable hard drive, starts with policy. What are our policies on portable media? Who can bring something into the office and connect it to carry a report home, for example? We should have clear policies on what's allowed in this case, and maybe only use a USB that has encryption ES-256 encryption, so that even if that USB was lost or left somewhere, it's not going to release the data that's on it. It's encrypted, and maybe even after a certain number of times would delete the data on that USB drive. Again, clear labeling is a good idea. We've seen cases where USB, for example, was color-coded. The ones that had sensitive information were a different color, so everybody knew right away, hey, be careful with this. It cannot be used for non-sensitive information or shared with anybody else because there could be residual data on it. But good labels are important, so we know that this requires protection. We always have to worry about reuse. If we've had portable media that's had sensitive data, is it possible for the next person to be able to access those former reports or files that were on that media? And clear policies should be in place to ensure that we protect data from being able to be gathered by a subsequent user of that media. This could require proper destruction of these portable drives as well. The key points review. Physical security is an important part of information security. It's important that we have facility security, and then we back that up because uncontrolled physical access can defeat most logical access controls. Access controls require regular review and maintenance at the desktop, network, data, and application levels.